There are basically three kinds of transformation that we will going to focus: translation, stretches, and reflection. Okay, translation, stretches, and reflection. Right. So these three transformation will going to happen in both way. What I mean in both way, translation will going to be happen in horizontal and in vertical. Same goes to stretch and reflections as well. That can happens, stretches can happens in a vertical stretch or the horizontal stretch. Reflections can also happens on x-axis, on y-axis, right? But how do I know that particularly the translation just happened, or how do I know that you know stretches just happen, right? Do we have any mathematical uh, way to understand that? Do we have any special uh, things to understand that? Okay, this is what just happens, that called translation. Yeah. Okay, so that is there, you're going to understand. The first that we are talking about, let's take one by one. The first that we are talking about here is translation, right? Translation, you can see what is happening in translation. I say translation can happen in both way, one in vertical, other in horizontal, right? See, what is the function that we have given here? That is x square, right? X square was the function, and which is my x square function? This is my x square function, right? This is my x square function. Y is equal to x square. Now you can see this red color graph actually shifted its position little bit right and little bit upside, isn't it? It shifted little bit right and little bit upside. It means if this was my initial coordinate here, which was x is 0, y is 0, now it's become h comma k. The new turning coordinate here is h comma k. What it means? It shifted h unit to the right and k unit to the top. Are you getting that? It shifted h unit to the right and k unit to the top. So mathematically, how do I say that this transformation is happening? So original function was x square. Now this new function which I am saying is gx. It's happened because it's shifted h unit to the right and k unit to the upside, upward, right? Okay, so whenever we have horizontal translation, remember, whenever we have horizontal translations, then mathematically represented as represented as f x minus h. Yeah, exactly. It's inside in the bracket. That's what the horizontal translation representing. Yeah. So it can be the both sign. It's not just minus h. It can be plus h if it is on the left side shifted, minus h when it is shifted to the right side. and vertical translation mathematically represented as a function fx plus minus k. If it is plus k, it means it goes up that much unit. If it is minus k, then it means goes that much unit down. Right? Here we have all the points on translation to remember. For y is equal to fx plus b, the effect of b is to translate the graph vertically b unit. If it is greater than 0, it moves upward. If it is less than 0, it's moved downward. Y x minus a is effect of a to translates graph horizontally through a unit. If a greater than 0, it moves to the right side. If a is less than 0, then it moves to the left side. Right. And if f x minus a plus b, it means translated horizontally a unit and vertically b unit, represented by the translation vector ab, a representing that horizontal one, b representing the vertical one. All right. Try this one. Minus 2 minus 5 lies on the graph y is equal to fx. Find the coordinate of the corresponding point on the graph gx, which is translated 3 unit to the right and 4 unit to the downside, that is negative 4. So now let's understand. Yeah. So always write, see, this is how you're going to solve it. Whenever you have to show the horizontal translation, always write the coordinate with its reverse sign. You can see here -3, but since it's in the structure, what is the structure? A structure is x minus a. It means if a is positive, if a is greater than 0, then it is just x minus a. But what if a is less than 0? I mean negative. Then what it would be? It would be x minus of minus a. Then it looks like x plus a. But the number was negative. Here we can see it is positive. Right. So whenever you see the things in horizontal translation, the number should always written in opposite sign. So -2 plus 3 -5, but the vertical one is as it is. So if it is -4, -4, yeah. So the coordinate we got is 1 comma -9, right? So if this is my fx, then this is my gx. Okay, clear? Yeah, 1 over 9. No, 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 not -1 over 9. It's positive. -2 plus 3. So it's positive 1, negative 9. 1 over positive 1 over -9. It's not over. It's technically the way of writing. It's actually representing the coordinate. It's positive 1 comma -9. Okay? Alright. Number 10. The graph of fx is given to us, that is quadratic function x square minus 2x plus 2 is translated 3 units to the right to form gx. Now you need to create that function gx, right? So how the gx form? By translation of 3 units to the right. It means gx is nothing but f what? X minus 3. X minus 3. That's how we get the gx. Very good. So create the gx function. Mhm. So gx would be, so x is replaced by what? X minus 3. Wherever you see the x in the f, replace that with x minus 3. X minus 3 whole square. A square by, this is the 3 unit translation to the right, right? -2. So I replacing the x of f with x minus 3. because my g function is formed by the translation of 3 units to the right. Right. So my gx is actually f x minus 3. Okay. So expanding the bracket, x minus 3 whole square is a square plus b square, which is 9, minus twice of ab, 2 times 6, 2 times 3 is 6, 6x minus 2x plus 6 plus 2. So it is x square plus 9 minus 6x minus 2x plus 6 plus 2, 8. So it is x square, and then we have minus 6x minus 2x minus 8x, and 8 plus 9 is 17. So the gx structure is x square minus 8x plus 17. Can we do number 11? Vectors basically representing the coordinates. So don't confuse that vector is something new. Vectors. Just treat that as a coordinate, x comma y. It's not 0 squared. Don't confuse. We do not need to do squared here. What is happening? Just can you tell me what is the translation here? X minus 3. It means 3 comma 3 comma 2 plus 2 plus 2 plus 2 representing the vertical, minus 3 actually it's x minus a. So if it is, I told you, if you just see that note, if you have written that x minus a, right, x minus a is the horizontal, and the number by which it is translated is a. The number by which it is translated is a. If it is x minus a, then it means a is greater than 0. It means it is right side. right side translation. And if you see x plus a, it means your a value is a translation, but this time a is negative, a left side translation, right? It's plus a because of x minus of minus a. X minus, actually the structure is x minus of that number of unit, that number of unit. So if it is positive unit, shifted right side, and if you see negative number over here, it means it's shifted left side. Okay, so the translation unit of the horizontal is 3 and 2, right? 3 and 2. So originally it was 0 0, now 0 0 plus 3 plus 2, where it goes 3 2. So 0 0 become what? 0 0 become 3 and 2. In coordinate way, if you want to write in the coordinate way, it is actually 3 comma 2. 3 comma 2. What about the next one? Minus 3 9. So it is minus 3 plus 3 9 plus 2. Minus 3 plus 3 is 0. 9 plus 2 is 11. So in coordinate wise, it is 0 comma 11. Right, so it becomes 0 comma 11. Similarly, find the point of fx which corresponds to the following point of gx. Now, you have given the gx coordinate this time. In the B question, you have gx coordinate already given, but you need to figure out the fx coordinate, the original one. You have transformed one is given, but you need to find the original one. We'll do reverse engineering. We have the gx given, so we'll do the reverse engineering. We have gx given 1 6, and we need to reach fx. So while doing fx to gx, I do plus 3 plus 2. So while gx to fx, I'll do minus 3 minus 2. So it will be 1 minus 3, 6 minus 2. So 1 minus 3 is minus 2, 6 minus 2 is 4. So this is my fx. Minus 2 comma 4. Minus 2 comma 4. And the next one is minus 2 27. So that will be minus 2 minus 3 20. Yeah, that's minus 5. 27 minus 2. So minus 5. 27 minus 2 is positive 25. So this is minus 5 comma positive 25. That was the coordinate of fx. Done. Next we will going to learn about stretches. It's not that accidental thing. It looks like the stretches when someone got accident, then we call something stretches. In this section we study how a function can be manipulated to a stretch it function. So it's very relatable to the stretch of the real life that we got. What happens when we got stretch, right? You might have seen in sports, generally it happens in sports, the stretches comes out, you know what happens, ligaments tears, or suddenly the hands, the stretches, it happens like that. Okay, so in function also it happens. For example, if I have a very random function, for example, y is equal to x square, y is equal to x square, so it can happen the stretch to this function. What will happen, how it will be happen the stretch, this function can be lofted like this, become shrink towards the y-axis, or it can stretch like more than the actual one, like this. So either it shrinks, or either it can expand. So that's how the stretches looks like. Are you getting that? Mathematically, how do we know that stretch happens? Like we have just seen from the translation, how it looks like for the stretches. So here we have, you can see the original function is y is equal to x square, right? And what happens to x? You just multiply x with 2, but inside the bracket. What you did? Inside the bracket you multiply, right? But actually it becomes what? If you multiply the x with 2 inside it, it's actually become 2x squared. So it become 2 times 2 and x times x, so it is 4x square, right? So this tells you that you did a horizontal stretch, right? On the other side, when you multiply it by outside, like 4 times of fx, so you know what was fx? Fx was x square, and since you multiplied with the 4, so again it is 4x square. But since you're doing it by outside, so it is for vertical stretch. Okay, so when you giving any number to the x from inside the bracket, it means you actually stretches from inside, that is horizontal stretch. And when you multiplying the function from the outside, that means you're stretching the function vertically. Alright, so now I'm going to show you this thing through the Dasmos. Let me share my screen for the Dasmos. Here we are. Is it visible? Okay. So let's my original function is y is equal to x square. Okay. This is my original function. A simple quadratic function y is equal to x square. Now I want to do the vertical stretch. Now see the magic. I'll multiply it by 2x square. You can see the blue color line is representing the 2x square. Let's multiply that with 4x square. This green color line is 4x square. Let's multiply that with 10x square. 10x square. This purple color is 10x square. So every time when I'm multiplying that with a number greater or more greater in a positive way, what is happening to that graph? It is shrinking, isn't it? It's shrinking towards the y-axis. If I give a big number, for example, uh, uh, 20x square, you can see the black color. Now it's more towards the y-axis, shrink so much towards the y-axis, right? So that's what the vertical stretch is, right? The y value is actually becoming bigger and bigger for the same x value is still same, but the y value is actually becoming bigger and bigger for the same x, right? Okay, now see another way. When instead of giving a bigger number, giving the decimal number, for example 0.5 0.5 x square, what happens with 0.5 x square? Yeah, it got bigger. It means like if I do 0.2 x square, right? 0.2 is less than 0.5, it's get more bigger, right? More bigger. Let's do with y is equal to 0.1 x square. See, 0. X square is actually making it more huge size, isn't it? Right. So this is the conclusion of a stretching. Let's come back to the here we are. So y is equal to p times fx. Y is equal to p times fx, and if p is greater than 0, the positive number is the vertical stretch with the scale factor p invariant x-axis. So x point is not changing, only y point is changing. How it is changing? Each point becomes p times the previous one, previous distance from the x-axis. If p is greater than 1, for example that we have taken 2, 4, 10, 20 that I have taken, if you remember, just we have taken that value, points move further away from the x-axis. It was moving further away from the x-axis, coming more closer to y-axis, right? But if p value is in between 0 1, for example 0.5, 0.2, 0.1 that I have taken, what was happening? Points moves closer to x-axis, isn't it? It become more bigger and it's coming more closer to x-axis. Okay, and now if I do y is equal to f q times x, that is multiplying inside the bracket. And if q is greater than 0, this is my horizontal stretch. But what is the scale factor? The scale factor this time would be not q, it will be the reciprocal of q. What is the reciprocal of q? It's 1 upon q, right? This time my y axis is invariant, while y coordinate will be same, only change in x coordinate will happen. So each unit becomes 1 by q times of the previous distance from the y. If q greater than 1, point moves closer to the y axis, right? If it is like 4 times x, or 6 times x, or 10 times x, then it behaves like the p which is 0 and 1, with that was in vertical stretch, that move closer to the x-axis. Similarly, if q is greater than 1, it moves closer to y-axis. And if q is 0 to 1, that is 0 0.5, for example y is 0 0.5x, or f 0 0.1x, it moves further away from the y-axis. So this was that away from the y-axis. Okay. All right, come to the number question on stretches. Can you do that? What is your answer? Mhm. 2 is the right answer. But do you remember? First, tell me if it is saying that gx is f of 5x. What is the meaning of this? Horizontal stretch, isn't it? Horizontal stretch. What is the scale factor? A scale factor is 1 over 5. That's the difference. 1 over 5 is the scale factor. And when you do the horizontal stretch, remember your y axis is invariant. It not changes. Y coordinate will not changes in horizontal stretch. Similarly, in vertical stretch, x axis is invariant. On that time, x coordinate will not change in case of vertical stretch. So now come to the point. Given that 10 comma 25 lies on fx, this is my fx. Find the coordinate of gx. For the gx, my y coordinate will not change. It will remain 25. Only x coordinate will multiply with a scale factor, which is 1 over 5 comma 25. So it is 5 times 2 is 10. So what is the new coordinate? 2 comma 25. Yeah. Now can you tell me about uh, b? B, you have to do the reverse engineering because minus 5 comma minus 15 lies on gx, and you need to figure out the fx coordinate. So reverse engineering. Reverse. So one thing will be remain same, that is y. Y will remain same. So that coordinate will not change. Yes, that's right. Exactly. It will be minus 5 times 5 comma minus 15. So the coordinate will be minus 25 comma minus 15. Wow, that's great. You understood. All right. Mm-hmm. Describe the combination of transformation which transform y is equal to x square to y is equal to what? 2 times x plus 1 whole square minus 3, and then sketch this. So basically you need to write all the transformations that happen here. Now every time, so x square become this with what kind of transformation? This minus 3. This minus 3 is what? Vertical translation of 3 units downward. x plus 1. So this is horizontal translation of 1 unit to left. Then this 2 is multiplied. This is vertical, a stretch of a scale factor is equal to 2. Right? So we have all three transformations happen here. Okay? Okay? Alright. This is our last transformation to understand, that is reflection. Reflection. So we have two kind of reflection. One on the x-axis, another on y-axis. How do you understand that reflection happens on x-axis? No, that's minus sign will be outside of fx. Right. So very randomly I'm drawing the graph over here. Very randomly. This is my graph. A random y is equal to fx. Now I want you to draw the graph of y is equal to negative fx. So it will be like this. This is what? My y is equal to negative fx. Isn't it? And when I say draw the graph of y is equal to f negative x of the same, then you will draw like this. This is your reflection on y axis. That is y is equal to f negative x. Okay. Come to the question. combination, because it's not just one transformation, it's a combination of transformation. Really? Mm-hmm. See, it's a combination of only both reflection, minus of fx of minus x, right? So a reflection in the x-axis and the reflection in the y-axis. See, minus, minus. So I'll write a reflection on the y-axis and the reflection on the x-axis. Now if minus 3, I mean if 3 minus 7 lies on y is equal to fx, then find the transform of gx. So what will happen to 3 minus 7? It's both translation. It's both transformation, I mean. So 3 become minus 3 and minus 7 become positive 7. So in general, see, in general, if the coordinate is a comma b and only x-axis transformation happen, right? So on that time, the coordinate become what? A minus b. When x-axis reflection happens, suppose coordinate is first coordinate, a comma b. Now it's reflected on x-axis and come to the fourth quadrant. In fourth quadrant, it become a comma minus b. And same a comma b, if it is reflected on y-axis, then it is in the second quadrant. In second quadrant, what is the coordinate of a and b? It will be minus a comma b, right? This is on the left side, right? So in the y-axis reflection, ab become minus ab, but this reflection happen in both, in x-axis and y-axis. So both coordinate will change their sign. So 3 become minus and minus 7 become positive. A point on fx transform to point minus 5 minus 1. Reverse engineering again. So minus 5 minus 1 is the result of reflection, that is on gx. So what was the fx? Minus 5 is positive 5 and negative 1 was positive 1. How do I know it's opposite 1? Because this time it is reflecting on x-axis and y-axis both. So I also need to reverse the sign of x. I also need to reverse the sign of y. If it is any single reflection, then I'll just change the sign of, for example, if it is reflected on x-axis, then I'll change the sign of y. If it is, How do I know what? Okay, okay, I got it. So on x-axis, my gx should be like minus of fx, isn't it? Just minus of fx. This is my x-axis reflection. Okay, and what is y-axis reflection? My gx would be f of minus x. That is my y-axis reflection. But if you see here, your gx is minus of f minus x. It means it's both, right? Is it clear? All right. Okay. So, what we can do next time, I think we are done with the concepts of transformation of the functions. Only thing that we can do is practice more and more questions on reflection of function. Okay. So next time when we meet, we will going to take more and more exam style questions from uh, I I mean ASL uh, exam style questions based on reflections or uh, translation or stretches or the combination of all three or the combination of two or maybe the combination of all the three, right? So we can take more questions, okay, on that. All right, so yeah, that's we are doing it. So it's happens sometimes they put one marker questions like we have did in the last time also for the exponential one. So okay, let's start with the log next time, and if there is some kind of transformation comes in between, we will tackle that. I hope we are yes, yes. All right. Okay then. See you next time. Yeah. Okay. Bye. Take care.